Hey folks, Mr. Dell here. Hey, we are looking at solving equations, trying to find the value of the variable within an algebraic equation. So this is coming from CPM's curriculum math, integrated math 1, and this is section 6.1.3. This is number 6-26. So it says solve for x, check your solutions if possible, graph your solutions on a number line. Now keep in mind, when we're solving for any variable equation, right, we're just looking for that number that would put could replace that variable, and then you do the math to get an equal statement, right? So I could say maybe x is 1. And if x was 1, I would just do the operations here. 4 minus 3 times 1, get that number, times -2 minus 6 times 1 does that. And then ask the question, does that equal 10? And if it does, then x equals 1, right? So it's we can use guess and check and just keep trying numbers until we get the right number, or use algebra to manipulate this equation to get x alone and find out what x is, right? So this is what I'm going to do. I'm going to use algebra to do that. So I'm going to take -2 and I'm going to distribute it. So the first thing is I'm trying to clean this up so I can get my variable expression isolated, my x all by itself. So -2 times 4, -8, -2 times minus 3x, that all changes to plus 6x. And then I still have a minus 6x on the end there. Now, if I keep cleaning this up, what do you notice is going to happen? I have a positive 6x and a minus 6x. Well, sure enough, they actually cancel. Those become 0. So all I'm left with is just this -8 on one side. So when the variables that you're solving for a variable and the variable expressions cancel each other out, eliminate, then you either have two situations. You have either x is all possible numbers, x can be anything, or there is no solution. So what we do is we check our lasting number sentence here. And I look, I have a -8 and a 10. And I ask, are those equal? They're not equal. So if that's the case, if your number sentences are not equal at the end, then you would say, therefore, sorry, a little glitch on the program here. Therefore, so x does not equal 10. So therefore, x has no solution. Okay, so that's our answer. So if x has no solution and it says me to graph my solutions, well, I can't really graph my solution because there's no solution. So the number line would just basically stay blank because there is no values of x that would be on this number line, right? And then to check our solution, we really can't check our solution because x has no solution. So in this case, that's as far as we can go for that problem. So we would say, boom, x has no solution. Okay. The second one. Now, this one, we're trying to get x. We can sit there and guess. Maybe I put a 4 in here. 4 minus 5, 4 minus 1, and I want to see when do those equal each other? Well, or we use our algebra, and algebra says I'm trying to get my variable expression isolated to figure out what x is. So I'm not a big fan of the big fractions here. So what I'm going to do is try to figure out, I need a number to multiply both fractions by to eliminate the denominators, right? To cancel out those denominators to create an equation that is not a fractional equation. Well, we notice that 2 and 3 both can go into 6. So I'm going to multiply both sides by, and I'm going to actually multiply by -6/1 because I've got these numbers in the bottom are negative. So if I multiply both sides by -6/1, what that does is it gives me an opportunity to kind of do this simplifying, this cross canceling here. That -3 and the -6 cancel and would become a +2. So now I have 2 times x minus 1 on this side. Over here, this -6 and -2. -2 goes into, you can look at it that way, -2 goes into -6 +3 times. So over here, then that becomes 3 times x minus 5, right? So then I can clean that up by distributing. So I have 3x minus 15 is equal to 2x minus 2. Right? So now I'm again trying to isolate my x. So I want all my variables on one side. So I have to eliminate them from, I pick a side, and this side I'm eliminating them from. So I'm making that a 0. But what you do to one side, you always do to the other. At the same time, I'm going to go ahead and do that with my numbers because I'm trying to isolate them. Now I have, if I combine 3x and negative 2x, I get 1x, and that's what I want. I only want 1x. So at the same time, I'm going to eliminate this 15 from this side. But what you do to one side of an equation, you do to the other. So I'm just using inverse operations to isolate that variable to get that x all by itself. So right now, x is equal to 13. So according to my algebraic steps here, I'm saying that x is 13. So now let's check our solution. What does that mean to check it? We'll go back up to the original equation, which was x minus 5 divided by negative 2 equals x minus 1 divided by negative 3. And it says to check it, you instead of x, you plug in the 13, right? So I'm going to say, is 13 minus 5 divided by 2 equal to 13 minus 1 divided by negative 3? So let's check those. So 13 minus 5 is 8, and 8 divided by 2 is negative 4. So do I get that same thing on this side here? So 13 minus 1 is 12. 12 divided by negative 3 is negative 4. So sure enough, it does check out. And then graphing your solution, what does that look like? Well, on a number line, x is only 13. So if this is 0, over here is 13. What I need to do is just put a big solid dot on 13, and that says that x, that shows, well, it's on that number line that x is 13. A lot of times we use number lines when we're dealing with inequalities, right? Inequalities being greater than, less than, less than or equal to, greater than, equal to. When we have inequality statements, we use a number line and arrows. But just a one answer would just be one dot on the number line. All right, there we go.